Hello, everyone. Welcome to another Wolfram Language Design Review. I am told that this is the 900th episode of our live CEOing software design review uh, um, series. So quite something, 900 episodes. Um, I guess I've been
It's
doing a fair
interesting.
amount of work over the last 7 years or so that we've been doing this. Um,
I
and
believe we
lots of
were
other
in one of the
people.
first ones.
What's that?
I believe we were in one of the very
Oh,
early
really?
ones.
Oh, good. The All right, so now we're
Season one,
back.
maybe.
The In season 7 or season 8. We should do these in seasons, yeah. Um, okay. Molecule
Right.
value plot. Does anybody
So
know
this
what this
is,
gray stripe thing is, which I keep on seeing in things in 14.3?
it is something new with
Well,
documentation. So
I know, yeah.
it'll tell you how many the word count of that cell
Yeah, except
when
that
you're
it isn't
writing it.
telling me that.
Right.
So
So
maybe Natalia could check into what's actually happening there.
Yeah, I can check.
Okay. There's a period missing there. So this is the 2D. I mean, is there going to be a molecule value? Oh, there is right there. What do you know?
let's see. Yeah. So I've contacted Jeremy to get a like a more custom color function for this, but right now it's just using a rainbow, and he's going to get back to me for that.
Okay. And is color the only thing that, I mean, region value plot and georegion value plot both default to color, right? As their indicator. This is presumably modeled after georegion value plot. Is that correct?
Yes.
So, okay.
It has one interesting distinction in that, so for georegion value plot, the values need to always be numeric. But for molecule value plot, sometimes they'll be categorical. If you scroll there.
Nice. That's nice. And I mean, presumably we have a color rules setting, right?
So this one takes a color function.
Now, but it also needs color rules for the categorical case.
Okay, yeah, that's a
Right?
good
So you need to follow that.
yeah.
Um, Now, whether we want to display the legend in all cases is not clear to me. I guess it does in this case by default. And why
And you
does
can
this? I mean, you
right.
might just
So
want
why does it give a
colors,
label? Sorry,
right?
go
I don't
ahead.
know what this label is doing. Where's that coming from?
So it's for the name of the property,
I
right?
know,
So
but that has nothing to do with. I mean, I see, because this is always a built-in property. Is that correct? That
unless the
doesn't
user
seem right.
passes in, so not always. You can pass the second usage. You can pass in a list of values, and so in that case, you would then have to give a legend label option.
Okay, hold on. What about the possibility that you have a function as that second argument, say hash MMFF partial charge plus blah, 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 blah. Do you see what I'm saying? Imagine that
Yes,
that it's an as if association type thing.
right. That could be interesting. I mean, would that to me that speaks of supplied, but maybe it doesn't have to. I know that is a separate design discussion,
Yeah, I don't think we
but
need that. I think that here I understand. Um, I mean, I think it's just rather limiting to just say, well, I mean, other folk who are here, what like picking on Bob, do you see, I mean, I just don't know to what extent this is just like show me some standard property of each of these atoms and to what extent it's compute something about these atoms.
Many of the standard properties we actually compute on the fly. That's what molecule value does. So this would just use those values for the standard ones like Jason is showing here. One would want to also, I think, be able to include, use a function that would compute them on the fly, or if we don't
From the
take a,
existing properties, from these existing molecule value properties. Is that correct?
no, 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 you would supply a function yourself that it would then use on each atom. It would use it on the molecule and then, I guess, get a list of properties for the atoms. Or Jason, is that would be supplied by data? In other words, if you got 28 atoms in your molecule, you would provide a list of 28 values, and then those would be shown.
Yeah, but okay, in the case of data, in that case, how do you specify each atom? Is it positional or what?
Yes. So if you scroll down the third example, or yeah, that one. And obviously, I need to clean up all those zeros in that
What the hell is
example.
this? I don't understand what this is. Oh, this is the, I see, this is the position. What is this? This is,
So it's just a list of values, one for each atom.
okay, so there's many things wrong here. So first of all, those have units. So why doesn't this thing have units?
That's a good point.
So this is directly analogous to what graph does. Namely, you can either give a list, but I don't quite understand. If I said such and such arrow, okay, so those are the values, but there's also a highlight molecule. Is that correct? That just lets you highlight. That
So
correct?
it's just regular molecule plot. The second argument is what to highlight. And this is
I see.
basically a wrapper around that. It parses the input and then calls the molecule
I
for that
don't care what it
feature.
does inside. But I mean, what happens? How do I get both things done? How do I get the colors and highlight of a particular atom?
Well, so the coloring you're seeing here is how we highlight the atoms.
No, I
So one could
realize that, but I'm just asking. Let's say that I want a particular atom. So every carbon atom, where I mean, just as a naive thing, let's say that I wanted atomic number highlighted. Okay, how would I do that for each atom?
right. So then you could just use atomic number as the second argument. It would take it to be like numeric, and so it would give you the
Is that enough? I mean, but what other things can I give? That's my whole point. Is that okay? Let's try this. Okay,
Just
so
about anything atom-based in molecule value, right, Jason?
yes. And so there's a list of the most useful ones up at the top.
okay, so here, for example, that scale is probably not the right thing to be using here.
Right. So I have a heuristic to determine whether it's what do you call it, numeric data or categorical. Um,
Okay, well, so it failed in this case.
right. So a small number of integers should go towards categorical then.
Definitely. Why
Right.
not?
No, it
I
makes
mean, I
sense.
would say less than half a dozen integers, up to 5 integers, would be fine for categorical. But obviously, you've got to be able to say, I want this kind of legend rather than that kind of legend.
Yeah.
Does that make sense?
Right. So I could think of a way, it would be kind of esoteric. You would say plot legends goes to placed and then either bar legend or swatch legend of automatic.
Sorry, say that again. Plot legends, arrow, what?
Plot legends arrow um, either swatch
Yeah,
legend
that's not
or
terrible.
okay. So swatch legend or bar legend of automatic.
Okay, so now let me understand something here. If I just say something is confusing me here. Why is it so big? Okay. Can you give me a much bigger molecule? Who has a bigger molecule up their sleeve?
So ATP
is the one. Yeah, that's the one that I use a lot.
Okay. Very nice. Except for this, which is completely stupid.
Yeah, I think a two-color, like the red-green split, but not red and green, maybe red and blue or something like that might be more useful.
Well, I'm not horrified by the actual colors that were chosen, although that's something you do need to pick. But I mean, that's something you're going to need is the sequence of colors in the case of categorical data.
Yeah, definitely there.
But I mean, also just the scale here is kind of silly. Also, I'm very unconvinced about labeling this with atomic number. As I mean, maybe that's the default, but there's got to be a way to have that label or not have that label.
Right. So
Or have a specific label. I mean, if you were using MMFF energy and you were writing a paper and you wanted to include that, that particular label might not suit your paper, your manuscript, and you want to tweak it.
Yeah.
right. No, so let's see. It's meant to take the options of the legend function. So should be able to just give it legend label goes to, and if it doesn't work at the moment, then that's just because it's a bug.
Okay. That sounds good, Jason.
Okay, but somehow it flipped to above rather than below.
Right. So I guess made the automatic behavior to do placed below.
Well, then why isn't this placed below as well, unless I specifically say here placed above?
Okay. Yeah, because I did not set that
Yeah,
up.
that just sounds like a default bug.
Right.
Applying the defaults.
Okay, so the thing I'm confused by, so let's say I do the same thing here with atomic mass. Is that going to work? Probably. Don't really know. How about we say neutron? What other? Oh, I mean, obviously there should be an autocomplete. There should be a autocomplete for those strings.
Yes. So it should also be nice and parse like element entity properties, like neutron count. So no, but it will. If you wrap that in entity property at the moment, it should work. And obviously it should.
But that if it does fail, it's got to produce a message and not just produce that kind
Absolutely.
of behavior. What do you want me to say? Element.
Yep. Okay, obviously I haven't tested that very well. I have some examples using element properties.
Well, I don't even know what
Oh,
this even means because
right,
I think
because each element
it's just oxygen, and then it doesn't know what to do.
I was to say the neutron count is an isotope specific property because you're looking at an averaged value.
Yep,
So it doesn't have anything.
Right.
But it should do something better than this, like produce a message.
Basically,
Right.
a
So in
message
this
of what we
case,
just said.
well, so okay, so in this case, the property is returning a list of rules for each element type. And so should we how do I tell that it's not a good categorical value, right?
I understand. This thing is this, the entity property for each thing is this, but that will be fine. I mean, but where's the picture? That's the only
You have to
problem.
scroll to the right.
Oh. Well, okay, that's just a formatting thing. I mean, what this did is then okay. It's just don't let the picture go off the screen type thing. I mean, this is a little nutty, but it's not obviously wrong. Am I making sense?
Yes.
I don't think this is wrong. I just think that something was wrong with the formatting.
So I can talk to the front ender graphics folks about like
I
what
think so about how to make sure that this doesn't go. I don't know what this should do. they probably haven't dealt with this case. A very long legend. I think this is a corner case. I wouldn't worry too much about it. I'm having seen that the thing is actually there. I'm kind of thinking this is the right behavior. Okay, let's keep going here on okay, so unfortunately we don't have, I mean, you should have invited somebody like Jeremy D from graphic design. Maybe we can see if we can find them. Natalia, maybe you can see if you can find them.
Yeah, I'll get him.
And okay, so the things I want to comment on, okay, so if I do this and I say bond length, that's quite nice. I mean, yeah. Okay. So now the question is, I could give this, in the case of bonds, how am I specifying this? With atoms, I'm just specifying a list of values for each of the successive atoms in the atom list. But so this presumably has a, if I say bond list, that's got a bunch of bonds.
Right. And so the answer to your question is I don't actually have that set up to where they provide data, because the data, let's see, molecules often have the same number of atoms and bonds. And so knowing that, what do you call it, that the data you provide is for atoms or bonds, I couldn't think of a good way to do that.
So let me suggest a way. Okay, if you're going to get bond data, just give a list of rules. Bond 1, 2, arrow, blah, blah, blah. Do you see what I'm saying?
Yeah.
And I would support the following things. I would support a 1 goes to blah, 2 goes to blah. That's atoms. See what I'm saying?
Yep.
Or I would say a list of, A1, A2, A3. Those are the properties of atoms. 1 goes to A1, blah, blah, blah. Those are atoms. Am I making sense?
Mm-hmm. And you could even support like a list of 2 integers goes to.
That's what I'm thinking. 5, 6 goes to whatever, B1, etc. Or, basically bond 5, 6, and then whatever goes to whatever. See what I'm saying?
Yep.
Now, another thing that I think is worth supporting is something like atom C. Every atom C goes to whatever it is. Does that make sense?
Yes.
Okay, so that's what I have to say about that. Now, in terms of the function, I do think that color function scaling is an important thing here.
Mm-hmm.
Because that's going to determine, if there's some value. But for example, let me say that let's say that I wanted to have the log of the for some reason the log of the atomic mass. Okay, I would have thought that one should allow a pure function that looks like this. And I mean, in a perfect world, I don't know whether we have precedent. I think we do in the tabular situation for inspecting the function and figuring out what things we need to compute.
No, I actually really like that. We've been, let's see, so we're proposing molecule value plot and the 3D version, but what we've been thinking about this release cycle is how to specify stuff like this for biomolecules. And we only recently decided that we're going to do biomolecule value plot 3D, a mouthful of that name it may be. But the whole time I was thinking about how could you specify a function by which you color on and have it go by residue ID, by position, all that stuff. And this is what I was thinking about. Basically, exactly
Okay.
like this. And I thought it would require what do you call it? Supplied. But yeah, because I've never really gone into functions or looked inside
Well, I
of
mean,
them.
you can always do this by just extracting an association of all the property values, right, for a given atom.
Right. But it would be probably less more efficient if you looked inside the
Yeah,
function
I know.
and
So
saw.
ask the people who've been working on Tabula, okay? Because I think they have a way to do this.
Okay.
I see Jeremy is here.
Oh,
We are trying to color molecules.
Right. So Jeremy did get back to me, but I had some questions about the color functions that he sent, and so I was going to
All right,
iterate.
well, let's define it for Jeremy here, okay? There are two cases. There's continuous and there's categorical. Okay.
okay. Yep.
And I mean, I don't know what this is showing here. This is kind of weird. Oh, I see. This is just showing hydrogen at one end and carbon at the other. So we know, I mean, I don't think we can necessarily assume that bigger is better, so to speak, as in that we want to more emphasize the larger values. I think we have to have something that's perceptually uniform across the
Yep.
color space. So can we do better than this rainbow?
Yeah. I sent that. I think it's in chat now, but I thought the same thing. The rainbow is nice, but I wanted to even kind of wait for the colors. And then I sent a diverging one because some of these scales are center zero with positive, negative.
I see.
That's what I wanted to ask. So, I mean, that's something like you would test, like look at the data and say, this data is around zero. Like you basically have a
Yeah,
like
do we have a
diverging.
way to figure out, is this a 0-1 scale? How am I supposed to use this? Is this 0-1 scale?
Yes.
You should be able to just say color function goes to that. And
Well, I'm going to try something different here.
Mhm.
So, okay, so this is basically rainbow-like, but perceptually a bit better.
Right. Yep.
Does that work? Ah, no. Okay. All right. Seems okay. I mean,
and then the next one is the one that's
hold on.
Sorry.
I mean,
Yeah, rainbow got too light in the yellows, and so I kind of darkened up the yellows and evened out the blends a little
this is
bit.
just a very muddy color around here. Brownish color. Is there any way we can avoid that?
Not really. It's got to make its way through, orange to green, and also not be too light. But I thought it looked okay in practice.
Okay, fine.
Why not a color scheme that's just two colors on the extremes with white in the middle, and we blend through the three? From blue to
Because
white.
we don't know what we're looking at. We don't know whether we're looking at a scale from -2 to +17 or what.
Oh,
We just
okay,
don't know
there's
where the
that
center
too.
is.
Yeah.
Yeah, for these, I mean, we're assuming colors in the middle are just as important as colors on the end.
Yeah.
Yeah, so that's diverging where the middle's a lot less bright. The ends are kind of highlighted, the heavier weights. But that's assuming, it makes sense for this diverging weight on the ends versus the middle.
Look, basically the point is we're going to have a bunch of values. And I mean, this is something that hasn't come up before, or it might have done. Given a bunch of values, we want to morph the color scale. So we have a distribution of values, right? So for example, let's imagine that we have I don't know how to do this. let's say, oh, I can't be bothered to do this. I mean, I'm thinking of a histogram with a bimodal distribution, for example. Okay, or some kind of skewed distribution. I don't know how to apply. I mean, we could make it so that this is mapped, so we uniformize the distribution. Do you see what I'm saying? So let's imagine I have a distribution. Just looking at one of these yesterday. Anyway. Okay, so there we've got a distribution. Imagine our data is distributed like that. Okay. Now, one possibility is that we could de-distribute the data so that the data, we could take this color range and make it so that down here where there's no data, that's all just in that last bin, right? But we're taking the inverse of this distribution effectively and using that to determine how we're taking, I don't know, some Jacobian or something effectively. Does anybody understand what I'm talking about? We're trying to make it so that the space between samples is a more or less equal space in color space. Anybody understand what I'm saying? Somebody say it better than that.
I follow.
I
wouldn't know how to code it right off the top of my head, but yes, I follow conceptually.
Right. So I don't know if that's a good idea. I mean, that is what we would be doing then is the end result would be that if we have a molecule with 1 million atoms in it, that the distribution of colors would follow this distribution. We'd have about equal numbers of these different color blocks in there, right? But that means in this region, it's varying more rapidly. I mean, I'm surprised we haven't had this issue, actually. I'm surprised we don't have a setting for this for array plot. Seems like the kind of thing we should have. That sort of, so this is something, Natalia, maybe you can get this brought up in the graphics improvement meeting.
Okay.
But for these purposes, maybe we don't worry about this. Maybe that's a future setting for color function. But for right now, I'm not seeing this divergent thing as working. Because you know what I'm saying with the 0, if it goes from -2 to +17, how is that going to map onto these colors? Right? Unless those colors map onto the full range, in which case the white in the middle is at, I can't do the arithmetic very well, but it's at whatever it is, it's at 9 or whatever, and the -2 to 17. Get what I'm saying?
And what you would want is the 0 to be the white to be around 0 instead.
I would think so.
Okay, I was just making sure
But
that we're on the same
right,
page.
the white is around 0, and all the blues are scrunched up into the 0 to -2 range, and the reds are in the 0 to 17 range. Do you get what I'm saying?
Yeah. I mean, that's what makes sense to me.
Right. So, I mean, there may be some settings here, and this may be actually relevant for array plot and matrix plot and so on. I hadn't thought of this before. Some settings like 0 centered or something, where you basically take 0, you pin it at the middle of this color scale, and you take the minimum value and take the maximum value, assuming that they're negative and positive, and then distribute the color scale uniformly over those regions.
Yeah. Yeah.
But that's something not just for this. That's something for array plot as well. So I think for these purposes, let's just go with that first color scale. And now we also need a thing for a certain number of discrete elements. And we need to be able to say, we probably need some string values. Well, color rules. How would color rules work? I see. Color rules works based on value. So it's value, arrow, and then the color. Red, green, whatever it is. Does that make sense?
Right.
Mhm. And so we would want to use that when we had a small number of different values. You know,
And we
even
wanted
if we
perfect
had 100
control.
atoms, but we would still only have, you know, a handful of discrete values.
Yes. But by the way,
Right, but for
this is not an adequate usage message. This should show with more explicitly what does data look like. It's a list, right,
right.
of item, arrow, color, basically. So you should say item one, arrow, color one, blah blah blah, comma list, right? Because this is completely obscure. And if this is a property in a string, you should put quotes property here. Does that make
Okay.
sense?
Yep.
Quotes prop quotes or whatever. And then I guess we have the final case is the function where we don't entirely know how to implement it, but you're going to talk to somebody about that. But worst case is we're making an association. Do you understand what I'm saying? We're taking
Yep.
we're making for presumably molecule value has a way of just giving every property. If molecule value has a thing called association that just gives for every atom, it gives an association of all of the properties, then that would certainly be sufficient for these purposes.
Yeah, I can definitely make this work.
Yeah, okay. But I mean, there may be a heavily optimized version of that if we can. Okay. All right, what's next for this? So I think that's everything we wanted from Jeremy. Unless Jeremy has comments on that. I mean, I think the look of these things is probably going to be okay with these colors.
I thought so too. With the new colors, I was liking them. For
Okay,
discrete, my colors were meant to go well with color date of
right. Do we have your
116.
discrete ones?
No, I didn't think it was needed, so I didn't bother to give it. But my gradient was based on color data 116, and so it would go well with that color list, and that's infinite.
Okay.
Yeah, I agree. The examples I used with that color function are nice.
Okay. Now, I mean, there are other things here, like whether you label the C's and H's and N's and so on, which you might not want to do. If the molecule is a lot bigger, you might not want to do that. You might just want to have color. So how do I switch that on and off?
I do not have a setting for that.
We could do that. We can do that in MoleculePlot, right, Jason? So you could just accept the MoleculePlot.
Well, so MoleculePlot always shows every letter except for carbons. But
Right,
when
but
I
thought
did that,
we could change that, right?
Well, I think it
let's
might be
see.
nice to have an option. I don't know whether we need an option. I mean, the atom labels.
Right. No, I
Labels
mean,
and
so
label placements.
yeah, so atom labels is for putting other things besides the atom identity in there.
I see.
There is no exposed way to tell it whether to or not to show the atomic symbols.
Well, what other things like that are there? Or, I mean, have you never wanted that option? What's an even bigger molecule here?
I mean, so like just making a random biosequence and converting to a molecule.
Okay, all right, okay. So give me a biosequence.
So I usually go to the doc page for that to grab one when I need.
All right,
Right. So
here's a biosequence. Okay, so let's go. Can I just do molecule plot?
it should automatically convert that. But if it doesn't, then it will in release.
Not bad. Rather nice, actually. So I see. So these do have the letters inside, but it doesn't really bother one. That's okay, I think. I think it's okay. All right. What's next to look at here?
Let's see. Yeah, so there's the 3D version of this.
I
But
just
it's
looked at
basically the same.
yeah. Just looks at that. except that doesn't have labels for atoms.
Correct.
What's it doing? Is it now computing? Is it now trying to fold it?
Right. It's but not using protein folding. That is so actually that one might take a while.
What's it doing? Is it using force field?
Well, so it's a distance matrix embedding algorithm, right? So it goes through it tries to generate a distance matrix.
Yeah, right. From every atom to every other atom, what is its
It's got a bound, and then it
force?
comes up with a random distance matrix that meets that, and then it converts that distance matrix into actual coordinates, and then it tries to clean it up.
Okay, so this is a little bit.
Works wonderfully for small molecules.
I think we got a question here of what to do. And this seems like a quintessential machine learning story. I mean, this is ultimately, you know, figuring out the shapes of large molecules, which is a known to be difficult thing.
Yeah. Well, for proteins, we default to the ESM fold.
Right. Which, by the way, what's the status of having that fully local?
We're getting close. Jason needs to know how to wrap up a neural net in a system function, and I think we're still doing some testing to see how well it works on different sizes of sequences and things like that. I'm still looking at that.
Okay.
So,
Okay. Well, all right,
Right.
fine.
yeah, but we need, I don't know if anybody has done this for nucleotides, though, the equivalent thing for folding those
No, I
with a
get
net.
it. I get it. It's hard. Okay, but let's maybe we could look, see whether anybody's done that. But it's probably quite hard. But now, just so I'm clear, in the folding case, if you want to know the coordinates, you just say molecule of that thing. Is that right? How do you get out the coordinates? You've got the biomolecule. How do you get out the coordinates?
So the
Post-folding.
atom coordinates is the property name.
So as soon as I ask for that, it's going to try and do a folding and get the result, correct?
Well, even when, let's see, when you just make a biomolecule out of a sequence, it will automatically try and fold it and get coordinates before even returning the summary box to you.
But once you've got the summary box, you can just ask for the the atom coordinates property, right, Jason?
Absolutely.
Yeah.
Okay. So a biomolecule, any biomolecule will be attempted to be folded. Is that correct?
Yes.
Including, for example, if I say here, if I said instead of this, I said biomolecule. No, but instead of that.
So we have no folding method. It should, it probably won't give it, I mean, it'll probably just say, I got nothing to do with this.
Well, that's wrong.
Yeah. Well, so
no,
there
no,
it's complaining
no.
about the second argument. But
Okay, fine.
yeah.
So if I say here, biosequence translate, is that right? Is translate the right term? I never remember.
I think so, but Sutik would be the.
Yeah, I think that's the one.
Oh, come on. Okay, you guys will fix this.
Yep.
Right?
Yeah.
Okay. All right. So I think we're done with the stuff from Jeremy. Unless anybody knows otherwise.
All right. Goodbye.
See ya. Bye.
Thank you. So these ones are not terribly exciting, but they're useful.
Why aren't they just head of something? Why don't you just test the head?
Because things come back unevaluated when they're invalid.
I see. Okay. Okay.
Right. And so we you'll remember I really wanted to make molecule fingerprints a system function, but we moved that into the feature extraction area
Yep.
some time ago, and it was noted at the time that it would still be reasonable to have a molecule distance function
I think it
that
should be called
uses
molecule feature distance or something like that. Because molecule distance just sounds too much like it's an actual, molecules are things in physical space. And a distance sounds too much like an actual distance. Like in molecular dynamics, there's an actual distance between molecules. See what I'm saying?
Yeah, no, I'm not opposed to that name at all.
Yeah, Jason Biggs, that's exactly where my brain went when you told me about this the other day.
That it would be molecular
That I
dynamics.
was immediately thinking of some kind of intramolecular distance between atoms or something for molecule distance. And then you said, no, 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 this is for things like similarity. And said, oh, that kind of distance.
Do we
was
And
want
my
to call it molecule similarity distance? Is that a better name for it?
well, similarities are kind of like inverse distances. So that would be very confusing to say similarity distance. But um,
Feature distance then? Molecule feature distance.
So I
almost
like
feature.
molecule feature distance. I had wanted to call it molecule similarity, but there are so many cases where it's more useful to have a distance function. For example, creating a nearest function or something like that.
Yeah. And
That
everything else is based, has been built around distance instead of similarity.
it could also be molecule dissimilarity
Yeah, that's
because we have quite a
confusing. Every time you hear that, you have to think. See what I'm saying? Every time I hear dissimilarity, I have to think for a moment. What does that mean? Oh, similarity means whatever. This is one minus it or whatever.
Right, and it could also, for the uninitiated, think that you're trying to compare molecules. Like, does this have the same functional group? Does this have the same number of atoms? That sort of thing. When you're
Well,
thinking
so
about dissimilarity.
fair enough. So molecule feature distance would go with feature distance, and it would have either a third argument over the extractor if necessary. Well, or you could have this option for feature extractor.
right. The third argument would be convenient because then you could have auto completions.
Well, so can you for the option, but also the main thing is look at that operator form. Feature distance.
So I really like that
extractor.
operator form, but notice that feature distance doesn't allow you to give feature distance doesn't allow example one, example two, close bracket, meaning so I do
I see
like
what you're
that,
saying.
but would it make sense to have like a two argument form with two molecules, a one argument form that is giving the name of the extractor, and then the full
No,
three
actually,
argument form?
this is not right. I mean, what we should do is, because there's also molecule distance. I can imagine you want to set up one molecule, and then you want to. I mean, I don't know whether maybe this doesn't make any sense. Maybe it's no more efficient to compute the distance to that molecule, the feature distance to that molecule, from that one molecule to all others, as between pairs of molecules.
Yes, that's a very common thing to do in drug design. You've got a molecule that you're interested in, and you want to know what your library is compared to that.
Fair enough. Well, so then a molecule feature distance of mol1 could give you, I mean, what would it give you? It would give you a feature, some kind of feature extractor function, I guess. I'm not sure. I mean, the question is it more efficient to do that, or are you going to end up doing pairwise comparisons anyway?
Yes, but they're fast.
Okay, fine. So
Generally.
then it's not. So then mol1 might be a convenient thing to have. But look, the first thing to have is just molecule feature distance with mol1, mol2. And then your feature extractor option is fine.
Yep.
And then the question of whether we want a molecule feature distance of mol1 as an operator form, I think is a separate issue, which I don't think we should worry about yet. Make sense?
Yep, absolutely.
Okay, anything else we need to go over here?
That was all I had.
looking good then. Yes, but let's get that local ESM fold thing working. That would really be nice to have.
Yep.
Okay, I mean, definitely for 14.3, right?
We've got how long until the code freeze?
Not long.
I
But-
know.
That's why I'm pushing it. Okay. All right. Good work, everybody. See y'all soon.
Thank you.
Okay.